Hey guys, welcome back with Mrs. Struble. Today we're going to be discussing graphing linear equations. In this video we're going to learn how to understand the definition of what a linear equation is, and then we're going to practice graphing linear equations using a value table, or in other words, an XY chart. So let's get started. First, some vocabulary that we'll need to be familiar with. A linear equation, what is it? Now, a linear equation is an equation in terms of x and y, or one or the other, whose graph is a straight line. And notice the keyword straight here. Lines can be curvy, wavy, zigzag, they can skip sections or be divided, but these are specifically straight lines. They have a pattern to them. They increase or decrease, or they move at a consistent rate, okay? The other vocabulary word that we'll need to be familiar with is solutions. Now, what is a solution itself? A solution is in a single point on a linear equation or on the line. Okay? Our solutions are going to be the plural form of that. So just the points on our linear equation line. So going into graphing these linear equations, again, we're going to focus on graphing using a value table or an XY table. We've got 4 simple steps here. So the first thing we're going to do is we're going to pick values for x. Now I like to keep those values low. I have go-to numbers that I just use, -1, 0, 1. And I always use 3 just because when I'm graphing it on paper, 3 is going to help me maintain that consistent pattern. Versus if I only have 2, then I really might not see the pattern throughout the whole graph, and I might find my line going away from that pattern. So I pick 3 values for x. After we've picked our values for x, then we use substitution and we substitute those values into the equation, making sure that first the equation is solved for y. Now to start us off with, all of our equations are going to be pretty much solved for y. So we'll get into how to rewrite the equation in a later video. After we have substituted, we simply solve that expression for y, and we plot those solutions that we found. So let's get started with an example. So our first example is y equals -2x plus 1. Now this is an equation that can be represented on the coordinate plane system using a line. And remember, x and y are just representing some sort of value. So we could be talking about the age of a tree versus its height over time, something that we've studied, we've collected the data on, and we figured out that there is a consistency here. Going into our XY table, they tend to look different depending on how you're wanting to do it. Now the basic XY table is literally just that. It's an X, it's a Y. We have our input x, our output y, okay? But I'm going to break it down a little further than that to kind of just show us what exactly is going on. Again, we have our x's, and then our output, we're going to end up with our y. Together, combined, the x and the y is going to give us a solution. So in fact, we're going to get several solutions here, 3 solutions that we can utilize to graph this expression, or this equation. In this section right here, we're always going to put the expression in terms of y. So if we have y equals this right here, this expression on the other side, that's what we want. So we're going to put that down here. And we're going to utilize that for our substitution. Okay? So again, with the x's, I like to just use -1, 0, 1. Sometimes it's not the wisest thing to use. Again, we'll get into that when we do more complex equations, when there's a fraction involved somehow. But for the purposes of this video, here we go. everywhere we see an x in this first instance, we're going to pretend it's equal to 1. So negative 2 times negative 1, well, that's 2 plus 1 is 3. We just found the first solution, negative 1, 3. That's a point on this line. What if x is 0? Well, then we have negative 2 times 0 plus 1, and negative 2 times 0 is 0 plus 1 is 1. We just found the second point, or a second point, on this line. And then finally, negative 2 times 1 plus 1, well, that's going to be negative 1. And now we have 3 solutions, 3 points on this line. We can go ahead and graph this linear equation and see what it looks like. I'm going to draw it over here. Excuse my rough sketch. All right. Now our first solution again is negative 1, 3. So let's review. We're going to start at the origin, which is in the middle here. Okay, we're going to start there. And the negative 1 tells us we're going to go left 1. And then 3 tells us we're going to go up 3. And we just graph that point. Let's graph the next point. 0, 1. Well, 0 tells us stay at the origin. And then we go up 1. We'll put a point. There's that second point. Now for the third point, 1, negative 1. It tells us we're going to go over to the right 1 and then down 1. And that's where our third point is going to be. We have 1, 2, 3 points. We can draw this line, more or less. Hold on. Human error here. Okay. It looks a lot nicer when you're given graph paper, so we'll be using graph paper for most of these. All right, and then we have our linear equation graphed. Now, unfortunately, as you all might know by now, math tends to be more complicated than the basic understanding of any topic. So let's think about what we're talking about. We're talking about linear equations. Linear equations are straight lines. And when we have straight lines, there are a couple more special cases involved. Can you think of them? The special cases I'm referring to, ladies and gentlemen, are horizontal and vertical lines. Now everybody show me a horizontal line. Okay, some of us, the other horizontal line. An easy way to remember horizontal and what it is think of the horizon. So horizon is straight across from left to right. So horizontal lines, those are going to be straight across from left to right. So now show me a vertical line. So if straight across from left to right is horizontal, vertical must be, yep, good. Okay, straight up and down. So horizontal and vertical lines. A horizontal line always passes through a point we identify as B. We'll learn later on that B is actually referring to something called the y-intercept, but we're just going to label it as B right here. So it is at the point 0, B, and whatever B is, that's what Y is. So oddly enough, or not oddly enough, but coincidentally, the equation is always going to look like y equals some number, okay? If you have y equals 2, for example, that means that we are looking at a horizontal line. On the other side here, vertical lines always pass through a point we identify as point A. Point A is going to be identified as our x-intercept. And the equation for such a line is in the terms of x equals some number. So, for example, x equals -5. All right. Taking into these examples into consideration, what would the XY table look like? Because we're talking about how to graph them using XY tables. So if I have an equation that says y equals 2, what is my xy table going to look like? And I'm going to do the shortened version of the xy tables here. And the equation y equals 2 says y is equal to 2. It does not matter what x is. So if y is always equal to 2, I can put any number under the sun for x. Okay? But I'm always going to get 2 for y. And that's just what the equation says to do. It says y equals 2. It's kind of like going to the movie theater, and the movies cost $5 for a matinee movie. And so you go on Monday and you ask them, well, how much is it? And they say, you know what? It's $5. And so you go, oh, no, that's too much. So you go back the next day, Tuesday, and guess what they're going to say? They're still going to say $5. Now, sometimes they'll do some price changes because of inflation or whatever. But if you go continuously for that week, Monday, Tuesday, Wednesday, Thursday, Friday, they're going to tell you the same answer. Okay? So y is equal to 2. It's always equal to 2 no matter what we do. Okay? It doesn't matter what x is. And so what does that line look like? Well, it literally looks like a bunch of dots in a straight line at y equals 2. Okay? Vice versa, not vice versa, but on the other side here, if we have an equation that says, hey, you know what? X is equal to -5. That means no matter what, x is going to be -5. I don't know what x stands for right now in this situation. Maybe it's the drop in temperature, because right now we're experiencing that. All right, but x is always going to be -5. So in this case, I do not have a choice of what x is. X has to be -5. It's the y that it really doesn't matter. I mean, y can be 13, it can be -12, it can be 1.008, okay? Whatever y is, x is going to be equal to -5. That's how we get all of those points. All right. Thank you for joining me on this video about graphing and linear equations. I hope you had a great time. This is Mrs. Struble with Struble Math. Have a good day, guys.